My name is Haoyi, and this talk is about Scala Scripting. So for the next 40-50 minutes or so, I'll be talking about how to use a Scala programming language for small-scale, one-off scripting tasks, quite different from the normal, large-scale application building, compiler writing, or distributed system tasks that you normally use the Scala language for. So as a motivation for this, I believe that Scala has a bit of a code size gap in that on one end, you have the Scala REPL, which is this really small thing that's really nice for writing small snippets of code. If you have a problem which causes compiler to crash or one-line, half-line demo to show someone, you can use the Scala REPL to quickly bang out something and show it this is what the code is, and this is what the output is. On the other hand, it doesn't really work well if the output gets large, because then it's pretty hard to read output like that. Or if your input gets large, not even very large. For example, this is a 3-line input, but if you make a mistake and you want to change it, you end up paging up line by line, trying to figure out which line you want to edit, and making sure you enter them back in the right order such that you can reconstitute the same command. So together, this makes it kind of hard to work with slightly larger bits of code. So although one-liners may work, 2-liners become difficult, and 3-liners get outright annoying because of this behavior. And on the other hand, you have SBT, which is great as a large-scale build tool. It works great for downloading external dependencies. It works great for dealing with internal dependencies between projects. So you can have a project with 15 different sub-projects, and when you ask for it to compile, it will compile the minimal set of sub-projects in the correct order to maximize the parallelism in order to compile those 15 projects and do what you want. But it's a bit of an overkill for small scripts. So for example, if you have this tiny Hello World application here, it's more or less the smallest Hello World standalone Scala application you can write. It takes a bit more than 3 seconds for you to run this application using SBT. And this is after the compilation is already being completed and all the class files are already cached. So you can see the Scala compiler is slow, and it is slow, but this is not the Scala compiler being slow. This is purely the build tool overhead. In comparison, you look at something like Python, it's 30 milliseconds, and Bash is 4 milliseconds. So that's 100 to 1,000 times faster. Apart from the time overhead, there's also the space overhead. So SVT leaves a lot of temporary stuff around your file system, which again doesn't matter if you're having a large scale, if I'm deploying to a cluster of 1,000 machines, I don't mind that there's a target folder on my build box. But if I'm trying to write a script that just mangles some files in my folder, I don't want this script to create another 104 folders and 59 files just to mangle one file in one folder. So that's why I think that Scala has a bit of a code size gap, in that in between the one-liners and the 1,000-liners, there's nothing that really fits writing Scala code. Many people will drop down to Bash for the one-liners that deal with the file system. Other people will drop down to Python for one-liners that may or may not deal with the file system, or maybe 100-liners or 200-liners that don't deal with the file system. But there is, at least in my opinion, no reason you can't use Scala for things from 1 to 1,000 lines. And what's lacking is a nice build tool that lets you write Scala and run it without as much overhead as SVT, but with more convenience in the Scala REPL. So that's where I think the Mlight project comes in, which is something I've worked on for the past 2 years, on and off. It gives you a nicer Scala REPL and a nice syntax for Scala Scripts, which lets you expand beyond what the Scala REPL does and lets you take care of things which are maybe too small to be worth a whole SBT project. So the Mlight is not a new project. So if the documentation's online, there's quite a lot of it. But in short, it has two things. It has a REPL that's like the Scala REPL, except prettier, so you don't feel so bad using it if you have lots of output or lots of input. And it has a script runner, which lets you run files kind of like SVT does, or the normal Scala executable. But it caches things transparently after compiling and runs it reasonably fast. So here we're looking at the first run, it takes 3 seconds. That's largely for compilation. And the second run over here, we're looking at about half a second. So this is still more than 10 times slower than Python and 100 times slower than Bash. But it's still almost 7 to 8 times faster than SVT, and maybe makes writing small scripts and running them acceptable rather than being a huge pain in the neck. So I'll just show off these two in series. So first, we have the Mlight Ripple. So this is something you can download from the website. You can add it to SVT project or use it as a standalone executable. It looks just like the Scala Ripple. You can do Scala Ripple things like 1+1, very important. First one is slow because the compiler needs time to warm up. After that, it becomes acceptably not so slow. What's better than the Scala Ripple? Well, you can do things like sys.env, and it shows you the output nicely formatted and colored. If you shrink the window, it correspondingly truncates at a shorter distance so you don't flood your output with lots and lots of text. And you can use show to print the whole thing if you don't mind flooding your output. It has multi-line editing and syntax highlighting. So for example, I could say def foo equals print line, hello. What? Sorry? Oh, sure. I'll make this like that. Can you see here? OK. So if I define a function like that, which takes up 3 lines, the first thing you might notice is that it's syntax highlighted, which makes it kind of nice to read if you have lots of code. Black and white code is difficult, at least for me. And when we deal with the history, you have a nice multi-line single block history editor. So you can go back and like erase parts of it, make it more excited. And when you're done, you run it, and all the changes have taken effect. So that's more or less the short demo of what the Mlight Ripple lets you do, and that makes it plausible for you to write slightly larger chunks of code than can be written using the normal Scala Ripple. For example, if you want to write that famous or infamous FizzBuzz interview question that people here use as a judge of programming aptitude, or whatever, you could say like, for x from 0 until 20, and x%3, x%5, then you match on it. Maybe they're both 0, in which case you print line FizzBuzz. Maybe the first one's 0, in which case you print line fizz. Buzz, or do nothing. And when you're done, maybe you don't want to run this yet, maybe you want to tweak it, maybe the interviewer asks you to say capital fizz and capital buzz. Maybe you want to go up to like 15 as an extension question to the interview because that's really hard. And then when you're done, you submit it and you get FizzBuzz, which is kind of nice. And so this is something which you probably can't do in a normal Scala Ripple, or you could do, but it'll be annoying. And it's also something you don't want to set up an SVT project to do, because setting up an SVT project to do a FizzBuzz interview seems way overkill. But with Mlight Ripple, things from like 1 to 5, maybe even 10, 20 lines of code, you can acceptably deal with them in the REPL. And if I want to go back and edit it, run it again, you can do so without doing the weird counting lines thing that a normal Scala REPL forces you to do. So that's the Mlight Ripple. While the normal Scala REPL fails when things get bigger than 1 line, the Mlight Ripple lets you scale a bit more, 10 lines, not quite web scale, but almost. And the next thing that I think that will show off that I think lets you scale from maybe 10 to maybe 1,000 lines is Mlight Scala Scripts. So Mlight Scripts basically let you take what you write in the REPL, dump it in a script file, and run it. So for example, if I look at a file here, let me make this bigger and turn this off. So over here, I have a file called foo.sc, and it says printline hello foo. And I can run it from the command line using amm foo.sc. You can also use a Unix like hashbang to make it directly executable if you wish. And this, after it compiles foo, it then prints out foo. As you see, if I change it, and let's say I add a time so you can see exactly how long it takes. The first compile takes more than 3 seconds. It needs to compile, and Scala compiler is slow. 3 seconds with like 3 threads in user land, apparently. And subsequent runs take like half a second, which is OK. It's not great. It's not nowhere near as fast as Python or Bash. You don't want to xargs 10,000 files and pipe each one through this individually. But maybe if you're running it as a standalone executable, maybe it's OK. So you can put basically anything, can put a normal Scala file on the Scala REPL in a Scala script. For example, if I want to place fizzbuzz in here, I can do so. I can take this, paste it, and I can run it. First time it compiles again, slow, prints line fizzbuzz. Second time it's acceptably fast, you get your fizzbuzz. So this is, so far, nothing that the normal Scala executable cannot do. So anyone here who's used apt-get install Scala or brew install Scala from Homebrew can simply run scala foo.sc, and it does the same thing, more or less. Let's see if that works. So first time should be a bit slow. Second time, it's cached and acceptably fast. So nothing special yet. So what makes Mlight scripts interesting? Well, what I think makes Mlight scripts interesting is the question to ask is, why don't people use Scala scripts for real work? I mean, people use Python scripts for real work. I've worked at a place where you have millions of lines of Python, and clearly it scales from 1 file to 2 files to 50,000 files. And you may not like it, but it works. But no one uses Scala scripts for real work. And I think the problem is it lacks 2 main features. One is, can you use third-party libraries? And one is, can you import other scripts? So the reason for this is that if you want to write any piece of code that does anything non-trivial, that's not a Hello World Programming 101 problem, you're going to need to use third-party libraries. Someone's going to give you YAML, and you'll need to parse YAML, and you do not want to write your own YAML parser. Or someone's going to want the OAuth token, and you're going to need some logic to create the OAuth token and do this back and forth to make the OAuth server happy. And you do not want to write that yourself. The second part, can you import other scripts, almost goes without saying, because if my script gets from 1 line to 100 lines to 10,000 lines, I probably want to break it into 2 or more different scripts just to keep it maintainable. But with a normal Scala script runner, this is not really plausible. So you can use third-party libraries, but you kind of have to manage it yourself using downloading jars and using the dash class path to pass the jars manually to the Scala executable or the Scala bootstrap jar. And you can do it. You can definitely do it. It's just kind of annoying to do. And you can't really import other scripts. There are some textured include things that can include things textually, but it's not quite the same. So with the Mlight script runner, this solves both of these problems, where it lets you pretty trivially import third-party executables using this import $iv syntax. And it lets you import other scripts using import file.foo or import file.foo.bar syntax. So for example, this import iv syntax is more or less equivalent to this snippet in the SVT build file. And these 2 import file syntaxes basically import those corresponding files and make them available to you as an object. You can call methods, you can use values, you can instantiate classes from them. And all of those are now available on that object once you import file.foo or file.foo.bar. The first one on the foo object, the second one on the foo.bar object, kind of like a normal Scala import. So let's show that off. So over here, I'm back to my foo script. Let's take a look at another script I've written called Scraper. So Scraper wants to use JSoup to connect to leehaoyi.com, which is my blog, and get all the headers from it, select all the H1 headers, get the text of those headers, and print them all out. So this is a kind of small thing you probably don't want to deploy to production on your Akka cluster, but maybe you want to do it because your boss wants to know who's hiring because he's looking for a new job. So if you try running this using the Scala REPL, the Scala script runner, it's called Scraper SC, you see it doesn't work because JSoup is not on the class path. And why should it? The Scala REPL is not a web scraper, so it should not have JSoup on it. And similarly, if you try doing it using Ammonite, it fails with the same error because Ammonite as a REPL and script runner does not have a HTML scraper. But just because it doesn't have it by default doesn't mean you shouldn't be able to pull it in without too much difficulty. And with the Ammonite iv syntax, you can import iv I think it's org.jsoup :jsoup, not JSON-P, JSoup 1.7.2. And this will pull down, this should, if I didn't make a mistake, pull down JSoup, cache it, and make it available locally on your machine. Looks like I screwed it up. Let's see. Nope, that worked, and I'm missing the HTTP prefix for my blog URL. http:// And first compile is slow as always, but after that it becomes acceptably fast. Again, it's still a few hundred milliseconds, but it's the kind of thing where you may feel okay with running it manually. It's not going to make you annoyed. You don't need to keep a continuous process daemon server SBT thing running. You just come in on your shell, you run it, you go on with your life, come back, maybe run it later, maybe you don't, doesn't matter. So that's JSoup. Maybe you want to do something else. Maybe you want to render some HTML. Similarly, Scala, if you want to use, for example, my Scala tags HTML rendering library, the Ammonite does not have Scala tags built in by default, so it can't find it, because why would a REPL need a HTML templating library? But you can import it. So if you import $iv.com.li Haoyi, : for Scala dependencies, Scala tags 0.6.2, and after that we still import the normal Scala tags thing. You can run template.sc, and we get our HTML out. First time is slow, subsequent times it's okay. The last thing to show off for the script imports is my neat little one-file play framework server. So this is in a file called web.sc, and while people talk about play framework as this big reactive web scale thing, all it is some jars and it is some Java objects. So you don't need to download the typesafe activator to do this. You don't need to have an SBT project with a bunch of plugins. All you really need is some jars and some imports and some instantiations. And again, you may not want, if you're going to work on this for the next 6 months, maybe you want to use an SBT project for the additional benefits. But if you want a server for the next 5 minutes, maybe you don't care. And if you run web.sc here, you can see this route there's a single route which routes hello with a segment, and it returns hello, that segment, as a string here. And if I go to localhost, I think it's 1900, I can do a hello Scala by the bay, hello foobar, or fizzbuzz. And you have a play framework server in this, let's see, in this much code, more or less. And maybe you don't want it, you kill it. Maybe you want it again, you start it up in about half a second, it's up, it's running, it's a play framework server, and you can get on with your life. So this is a kind of a silly demo, but there are actually many cases where I in person have had to start up a one-file Python HTTP server or a one-file Python like WebSocket server just for one small thing and throw it away later. And in that case, you don't really want a big heavyweight project. You just want one file which can run that does what you want and does nothing else. So this is what the Ammonite lets you do as a script runner. It lets you build larger things which are not buildable using the Scala normal script runner, but which are maybe too small to be worth the SBT project. And you can actually tie all these together because, kind of like Python, you can import third-party dependencies and you can import other files. And all the compilation and stuff gets handled somewhat transparently for you. So you may have to wait a bit longer, but when it's compiled, you don't need to have a separate compile and run stage. Or you don't need to have a long startup time even after it's compiled. So for example, I could take this play framework server and this web scraper and this templating engine, and I could hook them together because why not? They're just different scripts, and I can import scripts from other scripts. So if I want to render this hard-coded snippet of HTML from my play framework web server, I could, instead of printing out, I could make this script define a method that renders it. Render page equals that. On my play framework server, I could import file.template, and let's give myself a new line here. So I'm just do file.template.render page 2, and let's make the render page function take some foo to embed on the page. h1, hello, a paragraph of foo. So if we run this, compiling, and it should start serving. You see now we're getting back HTML for the page, and this is the HTML that is being rendered. This HTML that's being rendered by this script. So this script defines a render page object, and the render page object is this script defines a render page function on the script object, and when I import the script object in the main script in the web script, I import file.template. I now have this template object accessible to me, and this template object now has the render page function as you'd expect. So this is kind of copied from the Python semantics because I've used Python and I like it. And it kind of gives you a nice abstraction for here's a thing I can do stuff with. And in this case, the thing just happens to be another script. So I've made it render HTML. The other thing we could hook it up with is a scraper. So again, we had a hard-coded scraper here, which I could run using AMM scraper.sc to scrape my blog. And instead of using a hard-coded Haoyi.com web URL, we could define a scrape function, which then takes in a URL and puts these things on top in the function and doesn't print it out because I want to return it so the main web server could use it. So let's, instead of hard-coding Haoyi, I'll add it to a URL. Now if I run scraper.sc, it'll compile, but nothing should happen because it defines a function and then it exits because there's no actual code to be run yet. But what I can do now is I can import file.scraper. And I can say, well, instead of rendering directly the URL segment you passed to me over here, I can instead scraper.scrape the URL segment. I'm going to call it URL segment, it's a bit longer. And then, sorry? Sorry? Oh.
The argument to render page, I think.
Yeah, OK, I'll get to that in a second. The types are wrong too. Yeah? What? Oh, higher, sorry. Like that? OK, so I'm just going to call this headers because scrape, scraper, and scrape all sound too similar. So headers is what I scraped, and I'm going to render the headers as part of the page. If you try to compile this, it should fail because headers is a sequence of strings, and render page takes in a single string. So the solution is to go here and update the render page function, sequence string. Maybe I'll make this an unordered list with for header in headers, yield a list item, which is the header. And then we should be able to run that. So it looks like it's serving. And I could run here. It fails because there's no plain Scala by the bay. But if I do .io, maybe it'll work. Nope, that didn't work. Let's try lihaoyi.com. That hopefully should work. OK, so lihaoyi.com works. If you go to gizmodo.com, there's a bunch of stuff about animes and other things. Go to the New York Times. So by now, we've spent maybe 20 minutes, and we have a three file, I think it's maybe 50 lines, 10, 15, 20. Yeah, it's about 50 to 60 lines worth of Scala code in 3 files. And we can run it as a script form without needing to set up an SBT project. So this has the same advantages I showed you earlier. I could kill it, and I could rerun it, and the web server just starts up basically instantly as soon as the jars load, without needing to set up a big build framework or web framework infrastructure. If I want to add more things or more third-party dependencies, I can just import IV them as shown here, and they'll be made available as part of the class path. And you can just write code you can even write code top level without wrapping it into the object. Not because it's any magic, simply because it gets wrapped in an object for you, but it makes it kind of convenient for you to start off with small things. And it lets you scale up that small thing such that even when it's not so small, you can keep working in it, and eventually, when you're ready, you can convert it to a full-fledged SVT project, pay the cost of using SVT, and get all the many benefits that SVT gives you. So that's where I think the Mlight script format comes in. While the Mlight Ripple satisfies everything from 1 to 10 lines of code, you don't really want to be writing 30-line snippets in the REPL, even though you can. And anything more than 100 lines is probably totally out of the question. But you can write 100 lines in a script just fine. And maybe it's not worth paying the 3 seconds to start up an SVT project. But with the Mlight script runner, you can simply run the 100 lines in a script, and it starts up reasonably fast without all the overhead. So let's talk about some use cases. I've used this a bunch in various places, some of them very random. So my blog, which is Haoyi.com, actually is built using Mlight scripts. So let's kill Safari and go back to Chrome. If you go to github.com, the Haoyi blog, you'll see that all we have here is we have one page styles script, we have one pages script which renders HTML, and we have one build script which does the actual building. And you can just clone this down. Do I have it already? Maybe I have it already. Let's clone this down. Well, while it's cloning, we can take a look at what's inside each of these scripts. So build.sc, it pulls down peg down for markdown rendering, for markdown parsing, because the blog is written in markdown. It pulls down Scala tags for HTML rendering. It imports the page styles and the pages which are HTML pages. And it does a bunch of things. It formats dates using Git. It uses Java util date to format the dates nicely. So if you go to leehaoyi.com, these dates you have here are formatted using normal Java APIs, which are those. It generates a bunch of posts using for loops. It uses a peg down markdown library and overrides some stuff in order to give it custom like HTML snippets for parts of the markdown. And in the end, it removes the target folder, writes the HTML, and writes a bunch more HTML. And that's all there is to it. So there's no real framework here. All it is 3 files that you execute. While this doesn't give you any good defaults, it also gives you the ultimate flexibility. Like you could turn this into an Angry Birds app if you really wanted to. Like there's nothing that's stopping you from doing that. And it does a bunch of Git operations to push to the GitHub pages if that's what you want. Again, there's no plugin. There's no GitHub Pages plugin. It just shells out to Git, and that works great. If you look at the page styles, this is just CSS, and pages is just HTML. Pulls down Bootstrap because that's how you make things look pretty. Pulls down highlight.js because that's how you syntax highlight code on the internet. So that's one use case of Mlight. Let's see if it actually works. Blog and build. Yeah, so the first time you run it, the earlier ones, you didn't see this because it was already cached, but the first time you run it, it's going to pull down whatever it needs and compile everything. Compile. I don't know why it's compiling it twice. Then it runs its code, prints out a bunch of spam because it's a script, so I don't care about printing out things unnecessarily. And we're done. And once we're done, I can go into that folder, workspace, blog. All gets rendered as a target. And I have the blog as like a bunch of HTML that just got splattered out to a file. And if I run it again, it won't compile. It just does all the normal Scala code execution and does the same thing pretty quickly. Next use case would be Resume is an even smaller version of this. So this was generated using Scala. is like this much Scala with a bunch of HTML generation. The build script for Mlight itself, so Mlight has continuous integration using Travis and continuous deployment. So I set it up every time I push the master, it will get deployed to Maven Central using a commit, commit dash like OX00 whatever artifact. That is done using, again, using Mlight scripts. Let me paste this into Chrome. So it's an Mlight script, so you can import other scripts. In this case, I have another script that handles upload, just so I could test it manually. You can print line stuff all over the place because that's handy when it's a script and you don't know what's happening. You can check system environment variables. You can shell out to Git, you can shell out to Git. In this case, we're even like writing SBT files and executing them. Because why not? Like that's something you do in a bash script, right? If you're in a bash script, you'll be writing files and be doing stuff to them. And in this case, because the script is managing an SBT project, because Mlight itself is big enough, it's worth using SBT, this CI script just writes out SBT and shells out to SBT. So this is where it's writing the SBT file. It's writing more SBT files. At some point, it calls Sona type release, SBT Sona type release all. Let's see, I'll scroll this up a bit over here. So it takes advantage of the fact that SBT has a plugin to do this, to do the actual release. And for the parts that SBT makes sense, this happily delegates SBT. But for parts which SBT doesn't really give me anything I want, it doesn't really make sense to put everything inside SBT just because SBT is my main build script. I mean, for the things just like creating a file or making a HTTP request to GitHub, like, I don't need to wait 3 seconds just to make a HTTP request to GitHub. That doesn't make sense. So all that stuff is pulled out of SBT, and SBT is focused on just the building with all the random GitHub HTTP file mangling, all done within the Mlight script. And this is what gets run every time I push a new version of Mlight to the main GitHub branch. So those are the use cases I've seen for this. In terms of next steps, like this is a project that never really had a well-defined goal and therefore isn't finished. It started off as purely a REPL, and after that I realized that a script runner is just a REPL but with the commands pasted into files. So now it's also a script runner. But there's lots of stuff to do, and here are some of it. So as with most projects, it could definitely use more usage. Currently it's about 6 or 7K downloads a month, which is okay, but with more users, that always helps because more edge cases get found, more people can help fix bugs. And I guess probably most importantly, more users help set the direction of development because as in many of these projects, you could do anything, but just because you could doesn't mean you should. So ideally, this project would be something that's useful to a broad range of people. And in order for that to happen, I would need people to use it and give feedback on like what they want to do, what they want to use it for, and what they can't or don't want to use it for. Next steps, apart from that, you have more we probably need more contributors. So we've had a few dozen people contribute small fixes, but it's mostly been myself driving development. I was lucky enough to get 2 Google Summer of Code interns to help out over 2015 and 2016 summers. And they're actually the ones who built most of the script running that I showed you earlier. Like before that, it was just a REPL, and it's purely due to the interns that it became a script runner. But despite that, like most interns, they've moved on, gone back to school, and they're not really working on this full time. And I would need more people to help drive this project forward sustainably. As for concrete tasks to do, so now I've done all the hand-waving community stuff. There's a lot of actually pretty hard work that actually should happen in order for this to become much more useful to people. And many of these things are things which I have zero experience in doing and zero expertise in doing. So for example, IntelliJ support for scripts, item number 1. If you noticed earlier, IntelliJ thinks everything is wrong. And IntelliJ thinks everything is wrong because IntelliJ doesn't know what $iv is. And since IntelliJ doesn't know what $iv is, it doesn't know that play is being added, it doesn't know that this must come from play, it doesn't know that template comes from file.template means importing the file, it does not know that template then has a render page method. So it kind of works. You can still write code in it. It kind of falls back to a Vim Sublime level of coding. But it would be much better if we had actual IntelliJ Scala support for this. And currently, I've never worked with IntelliJ, and we ran out of time last summer to implement it during Google Summer of Code. Next, item number 2, convert autocomplete to use Scala 212 REPL's better autocomplete. So the Mlight Ripple's autocomplete is better than Scala 211's autocomplete, but Scala 212 is better again than Mlight. And the code is open source, so you should just steal it, but I haven't had time to steal it, and I don't really know much about the Scala compiler internals. So if someone could help me steal it and like chuck it in here, that would be great. Experiment using shapeless for more stable pretty printing. So if you look at the pretty printing in the REPL, for example, I could do seek.fill 110, and it you can see it prints it nicely for you. You can seek.fill like 3, 4, 4, 5. And it does this nice thing where it lays it out vertically as well as horizontally and tries to give it like for things which it needs to spread out vertically, it spreads out, but for things that can put out in one line, it fills out in one line, and it works for case classes and stuff as well. So I could do like option 1, 2, 3, sum 1, 2, 3. So this looks great now because I'm only showing you small examples, but there are lots of bugs with it where it fails to work. And that is because the pretty printing, like the derivation of trying to figure out what needs to be pretty printed, is done really hackily because I had no clue what I was doing. And the shapeless people seem to know what they're doing, so someone should go and try using shapeless to make it actually work for things like nested case classes or nested recursive case classes with sealed traits, where it sometimes works right now, but too often it does not. Better SVT integration. So currently, if you look at the main docs for SVT integration, you can run Ammonite as a standalone executable. You just curl it down and run it. Or you could add a snippet to your SVT project to make it runnable as part of your SVT test console. So then you can run it. You can run the nice REPL with all your SVT project stuff inside of it, all your class path loaded. But some basic things like compiler plugins aren't automatically given to the REPL. So if you have a compiler plugin inside SVT and you have a REPL, by default, the REPL won't have it unless you also add it to the REPL. And SVT plugins obviously don't affect the REPL. And compiler settings don't go to the REPL automatically. And these are things that could work, should work, don't work right now. And if someone could help do it, that'd be great. And lastly, there's Spark support, which is a hip thing apparently that I know nothing about. But since Spark uses the REPL a lot, and this is a nice REPL, in theory it should be usable for Spark. But because I don't really use Spark and I don't know anything about Spark, you would need someone who's like an actual user who cares about it in order to make this happen. I don't think it'll be that difficult. We just need someone to know who knows what they're doing to go and do it. So yeah, in conclusion, my view is that Scala has always had a bit of a code size gap, where small things are great, huge things are great, and small, medium-sized things were not so great, kind of annoying on both sides. And the Ammonite is meant to provide 2 tools to kind of bridge that gap. So previously, where you'll be writing a Python deployment script or a Python web scraper to scrape your competitor's jobs page or a Python whatever, with Ammonite, in theory, you could use Scala to do so. It won't be as fast to start up as Python. It's still more than 10 times slower. You won't have as much IDE support as Python, ironically, because although it's Scala, IntelliJ doesn't understand it, and IntelliJ actually does understand Python pretty well to give you all a nice autocomplete for Python. But despite that, the assumption is you people are here at a Scala conference, so you guys like Scala, and this could be something they'll be willing to try out if you want to try swapping out some of your Python scripts for Scala scripts, or your Python, IPython REPL work for Scala and Mlight REPL work. So that's Scala scripting, and I'll take questions. Go for it, Miles.
The thing that I'm realizing for that's absolutely lovely is the multi-line REPL editor editing. My own question is, do you have Vim bindings?
Please repeat the question.
OK, the question is, do you have Vim bindings for the multi-line REPL? And the answer is kind of. So if you look, So the REPL is basically written from first principles using Bash, using shell escape codes. So if you look at Mlight itself, the REPL is just like a sub-project, something like 1,000 lines of code is not a lot. And there are a bunch of like hard-coded bindings that we've implemented, and each one is basically hard-coded to do something. So we have some Vim bindings, you have some Emacs bindings, basically whatever anyone has felt they wanted to implement. We also have some GUI bindings, so we could do things like you can do things like select and replace things, or multi-line like tabs and untabs. So it's kind of a hodgepodge of things you can. Oh, sorry, you can't see at the back. So you have multi-line like tabs and untabs in the REPL, and you can highlight and replace things before I finally edit. So it's kind of a hodgepodge of everything that people liked. In theory, there could be more Vim bindings. I don't think it would be difficult, but you just need to add to this huge list of hard-coded bindings. Any other questions? One over there.
Have you thought about doing some sort of like a nailgun thing or some sort of like a background server? Because you talked a lot about the fact that it's not as fast as Mlight. So like,
Yeah.
the ways to make it faster are to have a hot JVM or to like use Scala native or something, and it's not quite right. So.
Yeah, so we've talked about using Nailgun and using Drip to have like a background JVM. My current feeling is that what we really want is something like SBTs, listen and recompile when files change, because that should get 99% of the use case. But yeah, you're right in that currently when you time it, if I go back to talks, if you time it, once you're done with the compile, most of the half a second is actually JVM class load time. So it's not going to get any faster until you can keep the JVM hanging around. So possibly Nailgun, possibly watch and recompile and rerun, but hasn't happened yet. So I would like it to happen. Any other questions? One over here.
Is this production ready? Can I go and replace all the scripts?
Depends how you question is it production ready? Can you go and replace all your scripts? The answer is maybe. So different parts of it are production ready to different degrees. The REPL is the oldest thing and it's the most production ready. So the REPL, I know lots of people at Twitter are using it because they've been asking for 2.12 support and I haven't given it to them. Like apparently Julie is using it for her scripts. I'm using it for my scripts, but if you want to replace all our scripts, you have to try it out and see what problems you run into. Like obviously, it will not be as polished experience as writing Python, at least for now. Like writing Python using IntelliJ is a really wonderful experience, and this won't be it until all those things I showed earlier are done. But you could start trying and see if it makes you happy. If it doesn't make you happy, roll back. Yeah. Any other questions? Going once? Yeah. Yeah.
Those are the shell ops
Yeah.
that you didn't talk about. Do you know if anybody's using the Mlight shell as their full-time like bash replacement?
I know a few people on the internet who are using it, which is probably a very unsatisfying answer. People on the internet have used it before and have given me like feedback about it. I don't know any large company that is using it on a large scale. For like that is answering the question of using Mlight not just as a Scala REPL but as a bash replacement. Who's using that? And the answer is people on the internet. Any other questions? Going once, going twice. I guess we are done. Thank you.